One of the things we did last year with FEMA was working on a project for hurricane relief, and we worked in conjunction with NOAA and FEMA for the Katrina hurricane that passed through New Orleans. This is a picture that was taken literally one day after Hurricane Katrina passed through New Orleans. And as you can see, if I zoom into certain areas here, here's some of the levees, and this is the big levee that actually breached. As I zoom in here, you'll see this area over here where you can see the actual levee breaching and the water coming in and pouring in over the levee. So anything due east of here, you can see very quickly all of these buildings here are flooded with water. And here again you can see the significance of having one picture where it can instantly zoom in on a specific building or specific area and then determine what kind of damage was done and where I need to fly with the helicopters to rescue people if rescue is needed. So this was one area where previously, right now, there was no way to even look at this kind of imagery within a couple of days. It was almost impossible to do. So with our capability, and responders out in the field could look at this imagery with the speed that I'm looking at it right now and instantly determine where there were areas of response needed. Here's another example of Pixia's core capability, which really addresses scalability and how can we handle massive amounts of information. And here's an example where we have an image that's extremely large. It's hundreds of thousands of pixels by hundreds of thousands of pixels. If you look at up here, you see these little jaggy edges. Each one of these was a separate file. So this area here, for example, was one single image, and it was then mosaicked or stitched together to create this one single large image. This image originally came from 7,500 individual files. So we took these 7,500 individual files, made one large NOO-ee file out of them, and this is now the ease at which I can move around in them. So if I want to zoom in all the way to where my crosshair is, that's how fast I can move in there. Let's go into, let's say, Andrews Air Force Base. I'm now in Andrews Air Force Base, and again, I can move around very seamlessly and easily. So before Pixia was able to add this capability of having this kind of a file format and file structure, every time that I moved on a conventional system, I would wait for literally tens of seconds, if not minutes, for the image to pop up. So our value add in this case is just the ability to instantly roam through the imagery and access it, was something that was previously just not, you just weren't able to do it. And again, because you have such a large area of coverage, this is the entire county of Prince George's County in Maryland. So this is the entire county of Prince George's County in Maryland at 6 inches per pixel. So pretty high resolution. Again, this is the native resolution of the actual imagery. And you can see that you can really see quite a lot of details. You can almost make out power lines and other things even from this image. But just, again, the value add that Pixia brings here is the scalability of, instead of having 7,500 individual little files, I have one picture that essentially covers the entire area. This was shot by aerial photography, so there was actually an airplane that took thousands of individual pictures, and then we created this one mosaic stitch out of it. And this image now could be used, of course, by the federal government for obvious reasons, but then also by local and state government. So the local government, in this case Prince George's County, can use this image to do infrastructure planning and all kinds of other things that they need to do, all the way up to tax property evaluations. You put up this pool here on this property, but you never let the government know about it. Well, they're going to find out from this picture and send you a bill after the fact now that you actually put this pool up and never told them about it. So this kind of high resolution imagery really allows you at a local and state level to recoup on your investment by increasing the amount of taxes. But as you can see from this kind of a high-res image, there's really a lot that you can tell in terms of infrastructure and in terms of other things that are needed. Another place where Pixia's technology can be used and we think of great help is for surveillance and reconnaissance. So as we have traditionally focused on individual still pictures, we're now focusing on streaming video and high-definition camera feeds. So in this case, we have a high-definition video camera that's looking at a specific area, and I can now traverse through time. So if I see an object of interest, let's say for example the school bus, I can now follow the school bus and determine where they're going. And you could see how this, for situational awareness, which is the military term for what we're doing here, which is essentially understanding at any given point in time what's happening in a certain location. I can move forward and back in time and see exactly who approached the site, and also after the fact, where are they going. Obviously, with what's happening right now with the IEDs, or improvised explosive devices, one of the biggest issues is to determine who actually put the bomb there, or the explosive device, and where did they go after they placed it there. So this kind of capability, with these kinds of surveillance capabilities, the value add that Pixia is bringing is being able to just access this data at all and being able to look at it this quickly. Again, before it took literally minutes and minutes to switch between frames to look at this. Now I can just visually track any object that I would like to track. Again, and speed and performance is the critical part here. So one of the things that Pixia is also very good at is essentially looking at images captured over a specific area, and images are usually captured either based on time, at a very specific time instant, or using different kinds of spectral combinations. In other words, like infrared, non-color based imageries. So here I have an image of 9/11 the day after, and as I'm switching through different spectral bands, different things will pop up. You'll see, for example, on the infrared band, all the regions of very high right is vegetation. So you can pick up all the vegetation in this image very quickly. But I can also switch between not just different spectral bands, but now I'm switching between different time segments. So if we go here, and if you look at the upper left corner of this image here, you'll see this was taken 1 day after 9/11. This was taken 3 days after 9/11, and this was taken 1 year after 9/11. So a year later, you can see the entire site has been rebuilt, and here you can see 3 days after, and this is the day after. You can still see the smoke plume. So the ability to very quickly navigate through time and spectral band, as it is called, as well as physically which portion of the planet you want to look at, the ability to combine all of those and do it so seamlessly and quickly really gives you a lot of information in a very quick time fashion. As I mentioned before, for Pixia, we're agnostic essentially as to the resolution and what sensor was taking the picture. For us, obviously, the more high resolution that the imagery is, the more you need our technology or our capability. Here's an example of an image that was captured by airplane flying at about 3,500 feet. But the resolution of the image is quite astounding. So as I zoom in here, you can see, for example, these two people talking to each other based on the time of acquisition of this image, the shadow that they've created. I can tell exactly what height these individuals are, and a lot of other information. So what we're hoping is that the imagery that I'm showing you here, this kind of resolution imagery, is going to become available of the entire planet soon. And again, this just shows, being at a low resolution like this, for example, versus being at this ridiculously high resolution, the amount of imagery that you're talking about just goes up exponentially. And we're sure that this is going to happen in all industries. So this image is on the Arizona border to Mexico, and if I go to a specific region here, you'll actually see footprints in the dirt here. I have this kind of a high resolution imagery of my border. You can see this small, very skinny fence here that's very easily visible in this image. And if there were actually individuals here that had been walking or driving along this path, like here you can see this road here, there are things that you can pick up with high resolution imagery that you just can't pick up even with the naked eye when you're on the ground. So by having this kind of high resolution imagery of your entire border, let's say between Arizona and Mexico, you could pick up just from the imagery where the porous regions are of your border, because you'd see the traffic on the ground. The footprints and tire prints would be left. Another area where our technology fits very well is the arena of biometrics. Essentially, the largest problem right now in biometrics is being able to match to such a massive database. And what we're able to do is to essentially, instead of having a massive database, just make one huge file with millions of individual records. So here's an example of where I have fingerprints of tens of thousands of individuals, and I can instantly navigate through them. But here I'm not using an actual database. I just have a simple flat file, which is a NOO-ee file in this case, stored on a disk drive, and I can instantly access it. So if I wanted to just see how fast I could access all of these, this would be the speed of being able to move through them. This is an example of where you can see just how fast we can move through the images. So in this case, I'm accessing about 200 to 300 fingerprints per second on a single computer. So this is the area that we're going into right now, and essentially it's the ability for someone to have locally on their person a database of all the really bad guys, let's say the top 50, 100,000 bad guys that they're looking for, and instantly once they take a picture with their digital camera, instantly match it to that database and see if they have one of those people that they're looking at. So this is one of the new areas that's evolving where our technology is making a big difference.